The nanoCAD program has a fairly extensive set of parameters for creating tables. Let's briefly go through the main elements and then gradually study each of them. First is the custom table, whose parameters we can set right from the table creation dialog box, or using the mouse cursor and left button we can specify the number of rows and columns. Similarly, on the left side of this dialog box, we can configure rows, data, footer, columns, and set names for the custom table. Next, load from database. This section contains already ready-made tables, which include ready-made templates. Next, load from file. The Browse button allows us to open the file. If you are uploading a document containing several sheets, then, accordingly, all the sheets from the file will be displayed in the query line. Click OK, after which we will specify the insertion point on the screen. Let's continue to briefly overview, and then we will examine each type of table separately. Next, Object-Based Report will open the following dialog box for quick selection. Currently, our drawing does not contain any objects. Therefore, we cannot open the next dialog box now, but with the help of this quick selection dialog, we will be able to create a report based on the properties that interest us. Next, import from Excel. To activate this item, the document to be imported must be open in Excel at the current time. And next, from clipboard implies that the table, which needs to be inserted into the current drawing, was copied to the clipboard. Also, in this dialog box, note that we can set the direction of rows and specify the insertion point of the table. Now let's return to the custom table. I suggest naming it Custom Table and set an arbitrary number of rows and columns. After which indicate the insertion point and the graphic area of the drawing, and this table will look as follows. When double-clicking on the table area with the left mouse button, the following table editor opens, in which we can enter data, edit it, and modify the internal structure of the table borders. Most of the commands are intuitively understandable, for example, alignment, text properties, borders, and so on. Let's look at the main part, that is how we can enter data into the cells. The first method, with the cell inactive, we can right-click and go to Cell Property. In this dialog box, we can enter values, specify the format of this value, check the box to prevent this cell from being edited later, and immediately from this dialog box, we can enter some kind of expression or insert a block. Next, tab Font, Fit, how the text will display inside the cell. Next, the cell borders and text alignment. Comments will be displayed as a green triangle in the upper right corner of the cell, hovering over which will reveal a link to the comment. And further presets for row formatting. If we activate this cell and again call up the context menu with the right mouse button, additional options become available for working with cells regarding text and any other symbols, and we can pick text from drawing, take some element properties from the drawing, or insert an object. Also, we can insert a field and a symbol. Let's try to insert a block into the cell. Let's go to Properties. Block. After which it can be aligned to the center. This is how a block is inserted. Similarly, we can insert geometry. For this we will use any drawing tool. I will use a circle. Then again open the table editor. Double-click to activate the cell. Insert object. Right-click on the geometry, zoom to text height, align it, and close the table editor. We can also open the cell properties and insert the geometry in another way. Properties. Insert object. Choose the circle. Zoom to text height. And close the command. Let's move on to the next type of tables from the database. We can use the annotation group and call this dialog box from here. Load from database, expand the list. And let's, for example, select materials list. Confirm the actions and specify the insertion point. Each type of table will have a table editor, with the same properties and with the same parameters for insertion into the cell. And let's now try using the next parameter, which is pick from drawing. Let's arbitrarily construct a rectangle. Open the table editor. Use the command pick from drawing. And the next dialog box allows to select a value. Immediately proceed to take from property. Select our rectangle, confirm actions, after which a property dialog box with parameters of this rectangle will open. Let's use the length, confirm actions. This value will be active, meaning if the contour of the rectangle changes, this value will be automatically updated in this way. Next table type load from file. I will use the folder in which I have prepared the data in the form of a table. Let's download this data from Excel file. And just look at what sheets will be displayed. This document will contain 3 sheets. In the query line, we can choose the sheet we need. Let's choose, for example, coordinates, confirm actions. Then you need to specify the insertion point on the drawing. This table from the file will have the same table editor with the same properties. Also, it should be noted, if the table was imported from Excel, you should remember that when a table from Excel is active, the button Update Table from External Source becomes active, meaning the Excel table is linked with nanoCAD tables. It will update after saving data in the Excel table. Let's proceed to the next table type, Object-Based Report. We will try to select some objects and make a report based on these objects. Next, the Quick Selection dialog box opens. Let's use an bounding box. It circles. Let's leave it unchanged and confirm actions. After which this field will display all properties that fill these circles. We can uncheck each of the properties, or on the contrary, create a report absolutely for all properties. Let's select a few of them randomly. Confirm actions, after which the following table with the properties we specified will appear. We can change cell properties by calling the context menu, where all properties of the selected circles will be located. We can also change, indicate what we need, and also we can create a new table if the table, as in this case, has many rows. Let's click anywhere in the column with the number of rows and call the next context menu, where we select the command Start New Page. A characteristic line will appear that will divide our table into 2 parts. This will become clear after selection. Using the editing grips, we can move part of the table and see that this table is a single entity. Meaning if we edit any data, they will be updated in the second part as well. Next, import from Excel. For this, it is necessary that a file with the table in Excel is opened. I have opened the table. Now I again go to the Create Table dialog window, Import from Excel, and confirm actions. After which the import of the table starts with the subsequent indication of the insertion point. Also, when data is changed from an external source, meaning if I now input data into the table randomly, save the changes. Then open the table editor and update the table from the external source. The update occurs, and in this way, our link is set up with Excel tables. We can also export this table to Excel, and the table will open in a separate Excel sheet. And next, from Clipboard. For this, I'll copy a table from Word. After which the line from the clipboard becomes available again. Confirm actions and insert the table into the drawing in this way. And lastly, what I'd like to mention is the compatibility of nanoCAD tables with DWG tables. We can insert DWG tables and customize the table style. A DWG table looks as follows. To edit it, you need to select the cell that we need to modify in some way. There's also the option of inserting a block and inserting a field into the table. We can also convert a DWG table into a nanoCAD table and vice versa. Now the table has been converted into a nanoCAD table. Let's convert a nanoCAD table into a DWG table. This is how work with tables is conducted, and we have covered all the main functions for working. That concludes our lesson.